So the next topic is transverse loading on beams and stresses. Okay. So in this topic, the different types of load is acting on the beam, that is a point load, uniform varying load, and a uniformly distributed load. Okay. This type of load is acting on the cantilever beam or simply supported beam or fixed beam. Okay. What type of stresses will be created there, and what is the maximum bending moment, so where the maximum bending moment will occur the inside the length of the beam, and also we have to find out the maximum load. Okay, that should be derived from the sum, that is the shear force and bending moment. The shear force is nothing but algebraic sum of the vertical force at any section of the beam to the right or left of the section. Okay, so that is nothing but shear force, and the bending moment is nothing but the algebraic sum of the moment of all the forces acting to the right or left of the section is known as bending moment. Okay, so what is the purpose of shear force and bending moment drawing? The purpose of the shear force drawing, the variation of the shear force along the length of the beam. So that's why you have to draw by using the shear force drawing, you have to find out how the load should be vary from one position to one point to another point. That should be clearly identified by using the drawing. And also the bending moment drawing, which shows the variation of the bending moment along the given length of the beam. Okay, by means of by using this drawing we can easily identify how the bending moment will be vary for the section of the beam. And what are the types of beam is available means cantilever beam, simply supported beam, overhanging beam, fixed beam, and continuous beam. Okay, this is the figure 6.1. It shows the cantilever beam. In the cantilever beam, one end is fixed, on the other end is free. And figure 6.2, it shows the simply supported beam. The two length of the beams are simply supported at the ends. Two end of the beams are simply supported at the ends. Okay, that is a simply supported beam. And the third one is the overhanging beam. The overhanging beam, it shows in the figure 6.3. The one at least one end or either two ends of the beams are over from the support. Okay, that is beyond the support. Okay, and figure 6.4, that shows the fixed beam. Okay, the two end of the beams are simply fixed. Okay, and figure 6.5, it shows the continuous beam is nothing but more than two supports, the beam is placed along the more than two supports. Okay, that is continuous beam. The what are the load is acting on the beam means the concentrated load or point load, uniformly distributed load, and uniformly varying load. The point load or concentrated load, that is nothing but the load should be acting at the particular point is known as concentrated load or point load. It shows in the figure 6.6, and the figure shows 6.7. It shows the load should be uniformly distributed over the length of the beam. Okay, that is uniformly distributed load. That uniformly varying load, it shows the figure 6.8. Okay, in which the rate of loading varies from point to point along the beam. Okay, that is nothing but uniformly varying load, that should be showing the figure 6.8. Okay, and the sign conventions for the shear force and bending moment is the most important thing. You have to remember the sign conventions. Okay, and what are the bending moment? Okay, that is the positive bending moment and negative bending moment. Okay, that's thing you have to know by. Now go for the sum. There is a cantilever beam of length 2 meter carries the point load is shown in the figure. Okay, so what you have to do means you have to draw the shear force and bending moment diagram for the cantilever beam. Okay, these are the things you have to do, and find out the where is the maximum bending moment and where is the maximum shear force acting on the beam. The total length of the beam, that is 2 meter. Okay, the different types of point load is acting on the beam. That is the different types of point load is acting on the beam, that is 300 newton, 500 newton and 800 newton. Okay, the shear force is nothing but, we already discussed, the shear force is nothing but algebraic sum of the all the forces, that is nothing but shear force. Okay, you go for from the point D, the point D, the load is acting is 800 newton. Okay, you have to take from the free end. Okay, so the free end, the what the load is acting means, that is 800 newton the load is acting, and the point C, now what you have to measure the calculation for the point C. Okay, so you have to take the previous load also for the point C. Okay, that is 800 newton plus 500 newton. Okay, totally 1300 newton of the shear force is acting at the point C. Now move to the point B. So you have to take the previous loads. At the point D, it's 800 newton is acting. At the point C, 500 newton is acting. At the point B, 300 newton is acting. Totally you have to sum of all the loads, that is 300 plus 500 plus 800. Totally the shear force acting at the point B is, that is 1600 newton. Okay, similarly go for the point A. Okay, so in between the point A to B, there should be no load is acting. Okay, so whatever the load is acting at the point B, the same load should be acting at the point A. Okay, therefore the point A is also 1600 newton is acting. Okay, now go for the bending moment drawing. The bending moment is nothing but force into perpendicular distance, that is a moment. Moment you already know, but this is force into perpendicular distance. Okay, at the point D, okay, there should be a force 800 newton, but there is no perpendicular distance of the point moment for the point D. Okay, therefore 0, therefore force into 0, that is 0. Next go to the point C. Okay, that is in the point C, you have to take the moment for the point C. Okay, that is 800 into 0.8, that is 640 newton meter of the bending moment is acting at the point C. Similarly go for the point B, that is 800 into 1.5 plus 500 into 0.7. Okay, now the totally at the point B, the bending moment is 1550, 1550 bending moment is acting at the point B. Similarly you have to calculate the at the point A. Okay, 800 into 2, 500 into 1.2 and 300 into 0.5. the finally the total load acting at the point A is 2350 newton meter. Okay, so the maximum bending moment acting at the point A and the maximum shear force at the point A. Okay, so you have to draw the bending moment drawing and cantilever drawing. Okay, so you have to draw the shear force drawing and the bending moment drawing. So in the shear force drawing you have to draw positive direction or either as negative direction. So the cantilever beam, the bending moment drawing is always comes under the negative direction. Okay, for the simply supported beam, the bending moment is always in the positive direction. Okay, because at the point A and B there should be no bending moment. Okay, so the supports there should be no bending moment. Okay, that's what I'm saying.